In this video, I'm going to explain what positive predictive values and negative predictive values are and how to calculate them. Hi and welcome back to Physiotutors. Before you watch this video on how to calculate positive predictive values and negative predictive values, you should know what sensitivity and specificity are and how they are calculated. If you want to learn more about that, make sure to click in the top right corner to watch our videos on those topics. Now, remember that in a clinical session, you do not know if your patient has the disease or not. So the positive predictive value of a test tells you how likely it is that the patient has a disease after he tested positive, and the negative predictive value tells you how likely it is that your patient does not have the disease if he tested negative. As the predicted values are always dependent on the prevalence of the disease, it is wise to first calculate the prevalence. And we do that if we take all the people who have the disease. So in this case, we have 220 plus 30, so 250 people who have the disease. And we have to divide them through all the people in our study. And those are 250 plus the 650 people who do not have the disease. So 250 through 1000. And we're going to end up at a prevalence of 25%. So the positive predictive value is the proportion of patients who have the disease amongst all the patients who test positive. So we have to divide all the true positives through all the people that test positive. In this case, it's 220 people who are truly positive divided through all the people that test positive. So 220 plus the false positives as well, plus 75. So in this case, we end up with a positive predictive value of around 0.75, which is 75%. Now, on the other hand, the negative predictive value is the proportion of patients who do not have the disease amongst all the patients who test negative. So in this case, we have to take all the true negatives, 675, and divide them through all the patients that test negative. So these two values, true negative, 675, plus all false negatives, which are 30 in this case. Then we're going to end up with an NPV of 675 through 705, which is about 0.96, so 96% negative predictive value. It's good to remember that you calculate the positive predictive value from the first row, and the negative predictive value is always calculated by the use of values from the second row. So if we go back to our prevalence of 25% that we calculated earlier, we can now say that the chances that a patient actually has the disease increased from 25% to 75% with a positive test outcome. On the other hand, if we had 25% of sick people, we also had 75% of healthy people. So the chances that a patient does not have the disease increased from those 75% to actually 96% with a negative test outcome. The good thing is that we can obtain the prevalence of a certain disease or injury that we see in our respective setting from literature. The problem is that we can only use the predictive values of a test if the prevalence is identical to the one reported in a study. So, for example, the prevalence of ACL tears will be much lower in a generalized PT practice in comparison with a sports clinic that is specialized in knee injuries. Therefore, the predictive values are not really useful in most cases, and the best and most effective tool that we can use are likelihood ratios. If you want to know what they are and how you can calculate that, make sure to click on the video right next to me. Alright, this was our video on predictive values. I hope this video made a lot of things clearer. If it did, give it a thumbs up or comment in the section down below, and make sure to subscribe to our YouTube channel and check us out on Facebook, Instagram or physiotutors.com. We'll see you in the next video. Bye.